Right, before we dive into details, I would like to welcome everybody. This webinar will focus mainly on the discussions about creep and shrinkage, and of course, creep and shrinkage in regards to prestress. So this webinar will be hosted by me, Ciprian Tibea, and my colleague, Fredrik Lagerström, which will answer your questions during the presentation. All right, now this is the map. Quickly, I will give you a brief introduction on our company, our products, and then we will go and discuss creep and shrinkage. So those are the locations on the global map where we mainly have users of our products. Those are some of our main products: Fem Design, Winstatic, Prestress, Impact, Impact Reinforcement, and Dimensions, but there are many more. And those are the offices that we have in the world. And now let's look at prestress and about at creep and shrinkage. So before I will open prestress, note that if you type on Google concrete creep and shrinkage StruSoft, you will get to this webpage where you can freely calculate and able to follow the calculation as well of your creep and shrinkage coefficients. But what is creep and shrinkage? So let's talk a little bit about the theory behind, and then we see how this calculator works. And then we go and take the data that we calculated here and take it into prestress. So let's start with creep. Creep is the deformation over a long duration of time at constant stress. Now, of course, creep depends on time, on the mix proportions, on humidity, the curing conditions, and the age of the concrete. And it has a big action at the start of the hardening process, but decreases over time until it becomes constant. So it's exactly like the hardening of the concrete. Shrinkage, on the other side, is the hardening process of the concrete when it's accompanied by a reduction in volume due to the evaporation of excess water. Now, in normal concrete mixes, we know that it contains more water than it's required for the hydration of the cement. And therefore, this normal water is what is causing the shrinkage. And of course, it depends on the humidity, on the temperature, on the shape and size of the concrete element, and the curing process, either if it's a normal moisture or steam cured. Now, probably you heard there are more types of shrinkage. It's chemical shrinkage, autogenous shrinkage, and drying shrinkage. Now, chemical appears in the first few hours. The autogenous shrinkage appears in the first days, and the drying shrinkage takes place within months. Yeah, so mainly we will focus here on the drying shrinkage. The first two are more relative for ultra high performance concrete, which have a low water cement ratio, and yeah, another theory behind. Okay, so let's take a look now at this calculation. As we see, we have the age of concrete, the concrete characteristic strength, though this is our input data, right? The cement type, and we can choose as normal, rapid, or slow. The relative humidity, if we press on this I, we see that those are the recommended values. If you don't have any measured values, you can use those, like indoors for 50%, outdoor 80%, and in very humid environment 95%. All right, now the cross section of the calculated element and the perimeter of the cross section, which is exposed to the surrounding environment. Now, yeah, those are like the age of concrete when loading started. It's considered like 28 days. Shrinkage, when the shrinkage starts, 7 days. So if we scroll a little bit down and click the Show Calculation button, we will see how the creep and shrinkage coefficients were calculated. Now, let's make some models and see how is creep and shrinkage influencing our models. And we give it without. This model will be, the first one will be without any creep and shrinkage. So we will use no values there, 0 value. Let's take a length of 12 meters, a rectangular. Sounds good. Maybe, I don't know, a higher one. Yeah, this one will do. And since we are focusing just on this creep and shrinkage, I will not add the fire load as I normally do. So yeah, let's place some reinforcement. Let's say 16 diameter top, 2 bars, and 6 bars, 6 tendons at the bottom. Right. Okay. Let's also place some stirrups, which we will make a little bit more tense this time. All right. And because I'm not actually interested in the model, I just want to see the difference between a model with creep and shrinkage compared to a one without creep and shrinkage, and those are the only variables between the two models. As you see here, long-term parameters, I have 0, 0. So I will just look at those particular stages, storage and maturing, and final stage long-term as a comparison. And as I said, this one, I will not even add any external loads. I will just analyze it as it is. So, yeah. All right, so those are our results. And we will mainly have a look on the displacements and the crack weight. So let's calculate code control. Those. All right, and we take those two results, right? Let me just use this snipping tool, and then I'll take this one. I open up a paint so we can analyze them in parallel. And then I will open another paint and we will analyze the cracks. So results, crack data. And let's take the first one, storage and maturing. And we copy the results. Probably there is an easy way to compare them, but this is the first thing that came into my mind. Yeah. All right. Let's even save it. And now we go back and we modify it, but we modify it accordingly. So what type of concrete do I have? Well, if I take a look here, I just use the default values, right? I have C35 in the storage and maturing phase, and in the final stage, it, of course, starting with the transport stage, it reaches its full class. So yeah, it's C40. Okay, now if we go back to the web page that I told you about, let's take in storage and maturing, I don't know, 28, 29, 30 days, right? We said it's C35. It's a normal class of concrete. It's outdoors, so the humidity should be 80, right? And let's take a calculator, calculate the cross section. I think it was 0.36. Yes, 0.72. Sorry, 0.36. We have 0.26. Yeah. And the perimeter, of course, is 0.72 multiplied by 3. It's 2.16. Yeah. All right. Calculate. 0.26 and 0.07. We adjust it a little. All right. Okay. And then we want to see the long term. So let's go to 1 year. We modify it to C40. And yeah, the rest. Now, maybe it's indoors, right? So let's modify that as well. And it's 1.36 and 0.32. Okay, so now we have calculated and inserted our long-term parameters. We can proceed with the calculation. Okay, let's first take a snapshot of this one. Great. Okay, and then let's calculate code control and have a look on the cracks. All right, let's take a snapshot of this one as well. Okay, so first, let's compare the displacements. So I see from the get-go that there is a difference when I apply the creep and shrinkage factors when I'm looking at this pre-camber. Yeah, starting with this phase onwards, the influence is higher and higher. And of course, if I'm looking at the final stage long term, I see an even bigger influence. So this is the influence when, taking an element without any external loads, except of his self-weight. And if we compare cracks, I see the first crack is in section 0.4 to 1 in the model without creep and shrinkage, and is 0.12, which is comparable to this one. But when I'm going to the next section, which is 0.48, I see that here I have 0.13. Here I have 0.14, so the crack width is higher. If I go further, I see 0.16, 0.17. So, and as I said, this is just an element with self-weight and prestressed. So we can already see that there is an influence. And if we are to compare, at the final stage, the influence will probably be even more visible. So let's have a look. And to compare those two as well. And this is the model width, creep and shrinkage. And let's go back. We save this one. Okay, so let's place the tables side by side. And again, at section 0.4 to 1, I have 0.08. Here I have 0.06, 0.09, 0.07. So the difference is even more noticeable when we move to the later phases of the element life cycle. All right, so mainly this was the aim of this short webinar, is to discuss and to realize the importance of creep and shrinkage coefficients. And if we want to have a really well-made design for our elements, we should always include creep and shrinkage, because they can make a difference sometimes. So I hope my colleague has managed to answer your questions, if there were questions during this webinar. And hope you like it and you learned something new. So thank you, and good luck in your designs.